Hi friends, welcome to the Warrior series of ABM. In Warrior series, as you know, we are covering all the case studies plus MCQs. Case studies are related to your previous year questions, even MCQs. Case studies will be numerical as well as objective questions. So we are covering the theory also. The behind this, whatever theory is there, we are covering that also. So watch the video till the end. Watch this complete series for all the subjects, not only ABM. ABM, BFM, ABFM, BRBL, all the four. So watch it completely. Today I will be covering some important questions related to Module A and Module C, both. Under the correlation method for calculating value at risk, holding period, confidence level, and a historical time horizon parameters are used. Change in the value of the position is calculated by combining the sensitivity of each component to the price changes in the underlying asset. The approach is deterministic and all of the above. So this method, this question is common for your ABM also and your BFM also, because value at risk topic is there in your ABM also and in your BFM also. Both the subjects it can be asked. So watch, tick the answer very correctly. It is useful for both the subjects. Yes, what is the answer? Holding period. See, VAR always comes with two, three points. Number one, confidence level. Okay, confidence level is very important part. Then mean, okay, and then it is others also. So holding period, confidence interval, and a historic time horizon parameters are used. Historic time horizon, okay. So it will be holding period is there, confidence interval is there, historical time horizon, that is also there. So VAR will include all the things, these three, plus change in the value of the position is calculated by combining the sensitivity. Now what do you mean by sensitivity over here? Sensitivity over here means standard deviation, volatility, okay? Standard deviation of each component to the price changes in the underlying assets. And the approach is deterministic. Deterministic means you have to be final. You have to get some final answer. So the answer is all of the above. All of them is the answer. Because all the three parameters are required over here for VAR. Which of the following method is applicable to any problem that can be formulated in terms of linear objective function subject to a set of linear constraints? So which method is applicable to any problem? Let it be any problem. So is it graphical? Is it simplex, using R and using open solver? Now these two are totally out. These two are not in your portion, nor do we study anywhere. The only question is graphical or simplex. Which method can be used for any linear LPP problem? Any of them? Yes. Is it graphical? Is it simplex? See, simplex is very long method. Those who don't know, simplex is very long method. It's a iteration method. It goes on iterating. Okay. So we have to find out the outgoing variable. We have to find outgoing ratio. We have to find out the incoming variable. So two things are there. It's a big process. Graphical method is a simple method, small method. But if you use it for computers, if you want to program it, programming, the best method is simplex. Any type of LPP, any type, it can be solved using your simplex method. But it's really difficult. In exam, kindly note, you don't have numericals based on simplex. You don't have it on simplex. Okay, on graphical you have it, but simplex you don't have. because simplex takes a lot of time. Next, you have in exam, you have the question on simplex method related to the theory. The outgoing ratio, the incoming variable, okay. 4 or 5 theory items are there, which I teach in the class. So join the class immediately. The new batches are starting. Okay, join the batch. Graphical method. Okay, graphical method is a basically diagram method. So that is useful. Okay. So the answer is simplex. Okay. From the population with a standard deviation of 1.69, a sample of 30 items resulted in 34.5 as an estimate of the mean. Find the standard error of the mean. This is the numerical which will come for 1 mark in your exam. And surely it will be there. So focus and try to give the answer. Let me see how many of you can answer. Yeah. Try it. Everyone try it. Very simple problem. Standard error. Firstly, tell me, is this population a finite population or infinite population? Everything depends on that, because the formula changes immediately. This is the infinite population. Why? Because do you know the final population, the size of the population? You don't know. So it's a infinite population. Infinite. Now, if it's an infinite population, then what is the formula? What is the formula for standard error for infinite population? Infinite population standard error equals to, yes, standard error, infinite population. Yes. It is standard deviation divided by root of n, sample size. This n is a sample size. Okay. And this is standard deviation given. So now find the answer. 1.69. So that is equal to 1.69 upon root of, what is the population given? 30 items. 30. So find the answer. 1.69 upon square root of 30. What is square root of 30? Everyone get it? Square root of 30. First get it, everyone. Square root of 30. Yes. It is 5.47. Okay, 5.47. So 1.69 upon 5.47. So that is known as your standard error. But what is the answer? But that is written as psi dash. Standard error is written as psi dash. So now get it, 1.69 divided by 5.47. Get it, everyone? 1.69. 1.69, get it? Yeah, 1.69 divided by 5.47. What are you getting? 0.308. 0.308. Got it, everyone? 0.308. So your answer is this. 0.308. A is the answer. Got it, everyone? A is the answer. What is the use of this standard error? Do you know? What is the use? Why should I use this? Why should I find this? See, standard error is having 3 parameters now. One is 68% confidence, means we call it 68.3% confidence. See, now your answer is over. But further, if in exam they ask you, find the resulting mean of the population, okay, using 68.3% confidence. So then the answer will be 68.3% confidence. Okay, if this is the case, then the answer will be 68.3 means 1 psi dash, 1 standard error. Okay, one standard error. So it is 0.308. So what will you do? It will be mean 34.5. 34.5 plus or minus 0.308. So now it will be a range, right? It will be a range. Range, what will be the range? 34.5 plus 0.308. So 34.8, right? 0.8, you can write it 08, means you can put it 1 also. 34.81, okay? With single standard error. And minus, if you do 34.5 minus 0.308. So it will be roughly what? 34 point, I'll take approximation, 2, right? 20, 1 point something, so take it 2, okay? 34.20 to 34.81, right? This will be the answer with single standard error. Now if in the exam they ask you 95.5% confidence, then it will be 2 standard error, 2 side dash. So it will be 2 into 0.308. So it will be what? 2 into 0.6. So directly take it 0.61, right? 0.61, you can take it. So what do you mean by this? That is equal to 34.5 plus or minus 0.61. So now find the answer. Again, the same logic. So 34.5 plus 0.61. So that is equal to 35 point something, 35.11, and this minus, if you do 33 point what, 989 something. So take it 9 only, roughly 9. So this is the answer for 2 standard error. Now similarly, I won't do it now. You do it for 3 standard error. Give me the answer. It will be 99.7% confidence. It is 3 standard error. Now you give me the answer. So 3 into 0.31 you can take it. Take this as 1 only. So 3 into 0.31. So 0.93. 0.93. So what will you do over here? What will you do over here? 34.5 plus or minus 0.93. Now you do this. Find the answer. Okay, for both. You try it yourself. What is the answer you are getting? 34.5 plus 0.9. Give me the answer now. It is 35.4, right? 35.4, right? 43. Is it so? Yeah. 35.43. And on the back side, 34.5 minus 0.93. So 33.5, 33.6 something, 33.57. Isn't it? 33.57. Get it correctly? 0.57, right? Yeah. So this is the use of standard error. See, in exam, if they ask you this much, that will be for 1 mark. But if they ask you all these, out of these 2 also, then it will be combined to form a 3 marks case study. It will be combined to form a 3 marks case study. Kindly note. Okay. So this case study can be asked, not can be, it will be asked in exam. This is for infinite population. Similarly, you can have a case study for finite population. There the formula is different. That will do it whenever the numerical comes. Next. Same thing. Choose the desirable properties of an estimator from the following options. Pure question in your exam. What are the qualities of an estimator? Good estimator. The chapter is from estimations only. Good qualities: unbiased, efficiency, consistency, and all of the above. So, what is the answer? Qualities of an good estimator. Qualities of a good estimator are, yes. What are the qualities of a good estimator? Correct? These three, all of them are required. Unbiased. It should not be biased at all. It should not be biased at all. If it's biased, then it won't give you the correct result. Isn't it? So, estimator should not be biased at all. Got it? Second, efficiency. It must be efficient. It must give the results. Otherwise, what's the use? Right? Consistency. It must be consistent. Every time you do it in any experiment, any atmosphere, or any with different set of numbers, it must give the similar answer. It should not change. Okay? Process should not change. So the answer is all of the above. Got it? It should be all of the above. Read the following statement and choose the correct option. Correct option. Now read this, everyone. Statement 1 and statement 2. Two statements are given. Statement 1, statement 2. Read this, both of them. Read it. Statement 1 and statement 2. What is statement 1? The central limits theorem states that the distribution of sample means approximates a normal distribution as the sample size gets larger. And statement 2, in central limit theorem, the average of sample means and the standard deviations will be equal to the population mean and the standard deviation. So which one is correct? The average of sample means and the standard deviation will be equal to the population mean and the standard deviation. Which one is correct over here? Statement 1. See, what is central limit theorem? Central limit theorem states that as you go on increasing the sample size, the tendency becomes more and more normal distribution, more towards normal. Okay? So that statement 1 is obviously correct from that. So means approximate to normal distribution as the sample size increases. So statement 1 is correct. What about statement 2? In central limit theorem, the average of sample means and standard deviations will be equal to population mean and standard deviations. So is it correct? The average of sample mean and standard deviation, average of these. Suppose if I do the average of sample mean and standard deviation, I'll do the average of these two combined. Means what? Sample mean plus standard deviation, sample mean plus standard deviation upon average 2. So that is equal to population mean plus standard deviation, right? For the population. Is it true? So this will not be true. This will always be, every time it will not be true. Sometimes it may be true. Sometimes it may be. But every time it will not be true. So if something is not true every time, you can take it as a standard then. Okay? In special cases it is true. So statement 1 is correct. Okay? Statement 1 is correct. Among the below mentioned, which of the following is or are the one of the key functions of the compliance department? Compliance key functions, module C and D combined. Idea dissemination, information dissemination, parameter dissemination and risk dissemination. Key functions of the compliance. Yes? Which of them is the key function of the compliance part? So the answer for the same will be dissemination, information dissemination, because compliance main job is information. The remaining things, idea, this will be done by the product team. Okay, parameter, These will be all decided by the product teams and audit teams. Information is the main part. Okay. So compliance's main job is this. Okay. So now, before going, everyone kindly note, join the Adda 24/7 classes ASAP. Okay. Join them ASAP and join the classes ASAP because, and I'll give you a number also today. You can dial on this number 0804-639-5886 and call the expert. So in this you will be getting the highest discount possible. All the discounts are available from this number only. So call on this number. Now one thing I'll tell you, how to join the batches. See, firstly call the numbers and go to Adda 24/7 and put all the, watch all the batches. JAIIB increment Mahapack, CIB increment Mahapack, everything. I would best suggest you to join the CIB increment Mahapack. Right now double validity offer is going on. Means what? See this. You buy for 6 months, you get it for 12 months. You buy for 12 months, you get it for 24 months. So it's very huge. Okay, double. Plus the discount offer is also there. Discount offer, you can see, put the code Y432. Click on enter. Look at this. 79% discount plus 1% extra. So how will you get this 79% discount? You can call on the number given and you can put this code also. You can try your own code. See this Y432. Directly you will get the 79% discount over here. Okay. 79% discount. So call on the number, put this code, enough, done. Join it ASAP because in the increment Mahapack you will be getting 15 plus batches per subject. Okay, best thing. Formula bank. Then main formula bank for all the subjects. Plus study planner. It's a huge thing. Join it ASAP. Okay. CIB increment Mahapack. And never forget the code Y432 and call